In the first part of this journey, we explored the giants we could still almost comprehend. Black holes, galaxies, and superclusters, massive beyond intuition, yet still confined within the familiar structure of the universe. But what if those were only the lower levels? What if beyond them exist patterns so vast that they no longer behave like objects at all, but like the skeleton of the universe itself? On these scales, galaxies stop being islands. They become particles drifting along invisible cosmic rivers. Gravity no longer pulls in simple directions. It orchestrates motion across hundreds of millions of light years, shaping regions of space we are only beginning to map. Some of these structures are so large that, according to our current models, they should not exist. And yet, the universe reveals them anyway, through subtle motions, distant flashes of light, and patterns burned into the fabric of space-time. This is where the story becomes unsettling. Because once we reach these scales, the universe stops feeling random and starts feeling organized in ways we cannot yet explain. This is not a continuation. This is a descent deeper into the architecture of reality itself. Laniakea, our cosmic home. When we think about where we live, we imagine a planet, a star system, maybe a galaxy. But in reality, the Milky Way belongs to something far larger. That structure is called Laniakea, our true cosmic home. Discovered in 2014, Laniakea spans more than 520 million light-years and contains over 100,000 galaxies. It is not just a cluster of galaxies, but a vast flow of matter, all moving together through space. Within Laniakea, galaxies are not randomly scattered. They are drifting along invisible gravitational pathways, pulled toward a mysterious region known as the Great Attractor. Over billions of years, gravity has choreographed this slow, inevitable motion, shaping the boundaries of the supercluster itself. The Milky Way is just one small participant in this immense cosmic current. Along with our neighboring galaxies in the local group, we are being gently carried through space, bound by a gravitational web so massive that it subtly bends the path of light. Laniakea is both humbling and poetic. It reminds us that the universe is not static, but alive with motion and interaction. Galaxies collide, stars are born and die, and matter flows like a cosmic tide. On a small blue planet orbiting an ordinary star, we drift unnoticed within this vast structure. And yet, from here, we look up and we try to understand it. The huge LQG, the cosmic Leviathan. According to the cosmological principle, the universe should look roughly the same in every direction when viewed on the largest scales. Matter should be evenly spread, without patterns too large or too connected. The huge large quasar group should not exist. Discovered in 2012, the huge LQG is a chain of 73 quasars stretching across nearly 4 billion light-years. To put that into perspective, it is tens of thousands of times larger than the Milky Way, forming one of the largest known structures ever detected. Quasars are the brilliant, energetic cores of distant galaxies, powered by supermassive black holes. They are supposed to appear randomly across the sky, but here they are linked together, forming a colossal structure held together by gravity across unimaginable distances. Its sheer size presents a serious problem for modern cosmology. Structures this large exceed the scale at which the universe should appear uniform. Some scientists have suggested it may be a statistical coincidence, an illusion created by how we observe distant light. Others believe it reveals something deeper, that the universe clusters matter on scales we do not yet understand. If viewed from afar, the huge LQG would resemble a glowing cosmic bridge, connecting galaxies like beads of fire suspended across the void. Whether anomaly or revelation, the huge LQG stands as a reminder of how fragile our models truly are. Just when we think we understand the universe, something appears that forces us to question everything. The giant GRB ring, a cosmic halo of fire. Gamma-ray bursts are the most powerful explosions in the universe. They are born from collapsing massive stars or the violent collision of neutron stars, and they appear randomly across the sky. At least, that is what we believed. In 2015, astronomers noticed something deeply unsettling. 9 gamma-ray bursts, separated by billions of light-years, were arranged in a near-perfect ring. Together, they formed a structure measuring 5.6 billion light-years across, far larger than anything that should exist according to standard cosmology. This was not a physical ring you could see directly. It was a pattern burned into the sky by the deaths of distant stars, a cosmic outline revealed only through extreme violence. On this scale, the Milky Way becomes meaningless, a speck lost inside the circle. According to current models of the universe, gamma-ray bursts should be randomly distributed. A structure this large and organized breaks that assumption entirely. Some scientists suggest it may be a relic from the early universe, a ripple left behind by the Big Bang itself. Others believe we may be seeing only a fragment of something even larger, a vast loop or wall of matter extending far beyond what we can observe. Or perhaps it is an illusion, a trick created by how light travels through expanding space. Whatever the explanation, the giant GRB ring remains one of the most disturbing discoveries in modern astronomy. A ring of fire drawn across the cosmos, whispering that the universe may be far stranger than we are prepared to accept. The Hercules Corona Borealis Great Wall. Imagine a structure so vast that even traveling at the speed of light, it would take 10 billion years just to cross it. That structure is the Hercules Corona Borealis Great Wall, the largest known structure ever discovered in the observable universe. Identified in 2013 through the distribution of gamma-ray bursts, this colossal wall of galaxies stretches across nearly 10 billion light-years. It is not a single object, but a massive, connected region containing billions of galaxies, each filled with billions of stars. On this scale, every galaxy we know becomes microscopic. The Milky Way is reduced to a grain of dust embedded within a cosmic mountain range that spans a significant fraction of the observable universe itself. And yet, according to our current understanding of cosmology, nothing this large should exist. The cosmic web, the framework of matter formed after the Big Bang, should not allow structures so vast and so interconnected. The universe, at these scales, is supposed to appear smooth. Some scientists argue the Great Wall may be an illusion, a statistical artifact created by how we observe distant gamma-ray bursts. Others believe it is real, a scar across space left by unknown processes in the early universe. Either way, its existence forces us to confront an uncomfortable truth. The universe may not obey the limits we have placed upon it, and if this structure truly exists, then the very foundations of cosmology may need to be rewritten. The observable universe, the edge of everything. Beyond every structure, beyond every wall of galaxies, there is nothing larger than the observable universe itself. This is the greatest stage of all, the totality of everything we can see, measure, and ever hope to understand. The observable universe stretches nearly 93 billion light-years across. Within this vast sphere exist roughly 2 trillion galaxies, each containing hundreds of billions of stars, and more planets than there are grains of sand on every beach on Earth combined. When we look deep into space, we are not looking across distance alone. We are looking back in time. The light from the most distant galaxies began its journey 13.8 billion years ago, shortly after the birth of the universe itself. Every image is a fossil, a memory carried by photons across eternity. And yet, this is not the entire universe. It is only the part visible to us, bounded by the limits of light and time. Beyond its edge lies more space, more matter, and perhaps realities we will never be able to observe. Inside this cosmic bubble, everything is connected. The atoms in your body were forged in ancient stars, scattered across space by supernovae, and gathered again to form life. In a universe of unimaginable scale, you are made of the same substance as galaxies and nebulae. The observable universe is both humbling and beautiful. It reminds us how small we are, and how extraordinary it is that something so small can look into the darkness and try to understand it. We have traveled from the familiar into the unimaginable. From the flow of galaxies within Laniakea to structures so vast they begin to fracture our understanding of cosmology itself. At these scales, the universe no longer feels like a collection of objects, but like a living system, moving, organizing, and evolving across billions of years. What we call the observable universe is not the whole of reality. It is only the portion illuminated by light that has had time to reach us. A vast cosmic horizon, defined not by the edge of space, but by the limits of time itself. Beyond it lies more universe, expanding, unseen, and unreachable for now. Inside this visible bubble are trillions of galaxies and uncountable stars, yet every one of them obeys the same fundamental forces. Gravity weaves matter into filaments and walls. Energy shapes birth and destruction. Time carries everything forward, indifferent to scale or meaning. And somehow, within this immense structure, a small planet formed. Life emerged. Consciousness awakened. And the universe, through us, began to observe itself. The atoms in your body were forged in ancient stars. The calcium in your bones and the iron in your blood were born in explosions that shook distant galaxies long before Earth existed. You are not separate from the cosmos. You are one of its outcomes. In the face of such scale, it is easy to feel insignificant. But there is something extraordinary about a universe that can give rise to beings capable of asking questions about its own origin. Curiosity, wonder, and the desire to understand are not weaknesses. They are the universe continuing its story. This journey ends here, at the edge of what we can see. But the universe does not end. It expands, it evolves, and it waits. Vast, silent, and full of mysteries still beyond our reach. Until the next journey, keep looking up.